In this video, we're going to take a look at some more problems involving union and intersection, and it's going to get a little bit tricky as we go forward, but let's start off with a simple-ish example. We've got some numbers, 1 to 10. We can see this from our universal set and some sets made up of those numbers, A and B, and we're going to find various different things. Now, I always think we should start off with a Venn diagram to help us, so let's put these numbers into this Venn diagram. And then it should be a little bit easier to work out some of these answers. So if we've got A and B they're given, we can see that 6 is in both. So I'm going to start by writing that. Then also in A I've got 2, 4 and 8. And in B I've also got a 3 and a 9. I haven't yet written out a 1. I haven't written out a 5. I haven't written out a 7 either, and I haven't written a 10, okay? Right, so from there, let's see if we can work out some of these answers. So first of all, the intersection of A and B, that's what this means. So that means things that are in A and are in B. Well, that's going to be 6. B, the union of A and B, well, that means the things that are in A or they're in B, okay, it doesn't matter. So this is going to be 2 and 4 and 6 and 8. That's all those elements in A. And also I haven't yet included 3 and 9 that are in B. So the numbers that are either in A or B. Okay, moving on. So A dash. So this is items that are not in A. Well, we can see here we've got the numbers that are in B that are not in A are 3 and 9. And as well as that, I've also got 1 and 5 and 7 and 10. So A dash is that set there, look. D, we've got to find B dash. Well, that is going to be the 2, 4 and 8 from A, as well as the 1, 5, 7 and 10 that are outside totally. So B dash is that set there, look. E, now then, we're going to get more complicated now. Let's see if we can think about this. The intersection of the elements in A dash and in B dash. Now, we can either use our previous two answers for part C and D to help us, or we can look directly at the Venn diagram. The things that are not in A and they're also not in B, well, this is going to be 1, 5, 7, and 10. Okay. F, the union of A dash and B dash. So this is a tough one now. So what we've got to do here, A dash union B dash, it means or. It's things that are not in, things that are in A dash or the complement of A. And you can have anything also as well that isn't in B. So we'll do these separately. So A dash is again going to be 3, 9, 1, 5, 7, and 10. And we can have anything that we haven't yet already included that is also in B dash. So we've included most of B dash, but we haven't yet included 2, 4, and 8. In fact, what this set really is, it's everything apart from that 6, because everything is either in A dash or B dash apart from that 6. Okay, I hope that makes a bit of sense to you. Let's move on, see if we can work out again some more answers to a more complex question. So in this case, we've got our universal set from 1 to 12, and we have 3 different sets going on, A, B, and C. So our Venn diagram is going to need to look a little bit different. Let's build it over here. So we're going to need to think about intersections of 3 circles, A, B, and C, to represent the 3 sets. So let's have a little think. Now, before we even get started, let's just think this through. Do we have any numbers that are in all 3 sets? No, we don't. Do we have any numbers that are in 2 of those sets? Yes, we do, because we've got 1 and 10 are both in A and B. So I'm going to write 1 and 10 there, but not in C. Okay, what about anything that is in A and C together? Yes, 3 and 6. 3 and 6 are in A and C, so let's write those in, 3 and 6. And is there anything in B that is also in C? No, there isn't. Okay, so that's the first part done. Now, what else have we got in A that we haven't yet included? Nothing at all. We've written out all the numbers for A. What about anything in B that's not been included? Yep, we still need to write that 5 in. So let's write that 5 there. It's not in either A or C. And then for C, we've already written the 3 and the 6. We've still got to write the 9 and the 12 in. So it's going to look something like this. Now, have we missed any numbers out? So I can't see a 2 or a 4 or a 7 or an 8 or an 11. So we're going to write those on the outside like that. And I think we're in a situation now where we can go for answering some of these questions. So let's get started. A intersect B. Well, what numbers do we have there? A intersect B, it's going to be things that are in both. That is 1 and 10. Part B, A intersect C. Well, things that are in A and they're in C. Intersection, that's going to be 3 and 6. Part C, B intersects C. Well, B intersects C. I can't see any numbers in B intersects C at all. There's nothing that corresponds to both. So instead of writing our list of elements, because there isn't any, we're just going to write that symbol down. As you remember, that means the empty set, the set with no elements in it. Let's carry on. D, we've got to do A union B now. Okay, so union means anything in either A or in B. So it's always going to be bigger, isn't it? So anything in A, well, that's 1 and 10 and 3 and 6. But as well as that, is there anything else in B we haven't yet included? Yes, there is a 5. So it's 1, 10, 3, 6, and 5. Right, E, A union C. Well, A union C is going to be anything in either A or C. That's going to be 1, 10, 3, 6, 9, and 12. Right, let's carry on. Let's take a quick look at F. C dash. C dash. Well, that means all the elements that are not in C. So it's going to be, in no particular order, 1 and 10 and 5 and 2, 4, 7, 8, and 11. That's all the numbers that are not in C. Let's see if we can figure out some more complex ones now. So I'll switch the color of my pen to make it a little bit easier to spot. So let's have a look at G. Now G, we've got A intersects C dash. So we're looking for things that are in A and they're not in C. Well, that has to be 1 and 10. Let's think about H. H is B dash, so that means that elements that are not in B. Well, in no particular order, we've got 3, 6, 9, 12. And we've got 2, 4, 7, 8, and 11 there. Okay. Right, moving on. Let's think about I. So B dash union C dash. They can be either in B dash or they can be in C dash. Doesn't matter. So let's write out B dash first. So B dash is going to be 3, 6, 9, 12, 2, 4, 7, 8, and 11. And then what else have I not included yet that isn't in C? Well, that is going to be 1, 10, and 5. In actual fact, that's every single element there. They're all going to be in that set. Okay, let's carry on. Now then, so here we've got something even more complex. We've got to think about A intersect B intersects C. So things that are in A and in B and in C. Well, there's nothing there, is there? There's nothing in the middle. So therefore we can say that that is going to be the empty set. Finally, A union B union C. So things that are in A, or they could be in B, or they could be in C. So that is going to be 1 and 10 and 5 and 3 and 6 and 9 and 12. Okay, So that hopefully helps you to understand some more complex questions with Venn diagrams. We've got one more example to have a quick look at. Let's just see if we can think about this. So all we're going to do now is say true or false for any of these statements. So first one reads, A is a subset of B. Well, that is true because the entire circle of A is inside of B. B is a subset of C. No, that is false because it is not contained entirely inside of C. Right. C, A intersect B is equal to A. So elements that are in A and in B, well, that is going to be all of them, isn't it? So that is actually going to be true. Absolutely true. A intersect B is equal to C. Well, that is certainly not true. That's false because there are elements in C that are nowhere near either A or B. A intersect C is the empty set. Well, this is true. These two sets, there's A, look, and there's a B, they're called disjoint. They don't touch each other. They have no elements in common, which means that their intersection is the empty set. So this is true. B intersects C is the empty set. No, that doesn't appear to be true from this diagram because look, there's this area here that there is going to be elements in. So that is going to have to be false. And then finally, B union A is equal to B. So all the elements in B, that's all of those, and all the elements in A, well, it's just going to be B again. So that is going to be true. Okay, I hope that this video has given you some ideas of the sorts of challenges you can get into with these Venn diagram questions, and it gives you more exposure to that set